Let's take this scenario where we've got a boat being pulled by two tugboats. They're attached to the boat using ropes and they're pulling at these angles. Thinking about what might happen, it's clear that the boat will move in this direction. However, how can we find out the exact direction of the force and also the size? To do this, we need to use a method called the Parallelogram of Forces, where we take the forces and we combine them into one resultant force, which in this case is the orange arrow. The resultant force is the diagonal of a parallelogram formed from the origin of the two forces. This is a geometrical method and we call it the Parallelogram of Forces. And in this quick video, we're going to show you how to draw these parallelograms. To get started drawing parallelograms, I think it's a really good idea to use a pen with three different colours. We're going to be using blue, red and green. And I suggest you get 3 pens of those colours or 3 pencils. So how do we draw the parallelogram? Well, we have two forces acting like this. It doesn't matter at what angle they're acting, the process to draw the parallelogram is the same. Now we know that a parallelogram has 2 pairs of parallel sides. So to draw the alternative sides, we're going to make them parallel. So for example, this dashed green line is parallel to the bottom, and this dashed green line is parallel to the left. There's only one place where those 2 lines will cross, and it's this opposing diagonal, here represented by the red arrow, that represents the resultant force. So let's have a look at how we're going to draw those resultant forces on some of those examples. So firstly, we need to draw the parallel side for this shape. We take our ruler, we line it up with one side, and we slide it along to the opposite side to the end of the arrow, and we draw our line. We then do the same from the other side. So we take our ruler, we line it up with this side, and again, we slide it up carefully to the end of the arrow and draw across. This creates our parallel line. Our resultant force is then drawn from the origin of those 2 forces to the opposite corner over here, like so. Not forgetting the 2 arrows to show the direction. Again, we'll do it one more time for the second one. And then we draw the diagonal line for our resultant force. So now you've seen how I've done it for the first couple, I want you to complete the parallelogram of forces for the forces on the page. If you're thinking ahead, you could have a go at working out the size of the parallelogram of forces in the bottom 4. So let's take a look at these answers. So here's the first 2. Firstly, you drew your parallelogram of forces. You drew the green lines to complete the parallelogram, and then the resultant force is the diagonal. If you were thinking ahead, how could we work out the size of this force? Well, these are called scale drawings, and so they're drawn to scale. If you measure it, you'll find that the scale in this diagram represents 1 centimetre as 1 Newton. Therefore, if we measure the length of our red line, we find out that it's 5 centimetres. This means that the resultant force must be 5 newtons. For the second example, again, you drew your parallelogram using green lines, and then the red diagonal here is the resultant force. Again, the scale is also 1 centimetre to 1 Newton, and so measuring the line at 6.5 centimetres means the resultant force will be 6.5 newtons. It doesn't matter that we don't have a 90-degree angle in these examples, the process is exactly the same. So for the first one, we draw our green line to represent our parallel sides. We draw the red resultant force from the origin to the opposing corner. Our scale is still 1 centimetre equals 1 Newton, and so measuring the line at 8.5 centimetres gives us a force of 8.5 newtons. In the second example, we do the same thing again. We draw our parallel line, and our opposing line from the origin to the corner represents our resultant force. In this example, the scale is different. The scale is 1 centimetre represents 2 newtons. Measuring our line of 5 centimetres means that resultant force will be 10 newtons. So that's our video on an introduction to parallelogram of forces. Watch our next video to find out more things that you can do using the parallelogram of forces.